So a little bit more advanced probability here. We're going to get into conditional probability. So let's take a look. Here's some situation. A school does a quick survey on the focus of boys and girls being in school, whether their focus is grades, popularity, sports, and comes up with these totals. So a great way to organize our data, we're going to see in this lesson, is in these two-way tables. So we're comparing, these two different things, their gender and their focus in high school. So from here, we can start to maybe pull some different probabilities. So for example, the probability we have a girl. So if we selected a student at random, the probability we select a girl, 251 out of the total, 478. The probability that we get a girl and their focus is popularity would be that overlap right there, 91 out of 478. The probability that someone's focus is just sports. So there's sports, the probability, and again, there's no stipulation. Is it a boy? Is it a girl? We don't care. We just want to say that there are 90 out of the 478 students that are focused on sports. Where we're going to get a little bit more in depth today as opposed to the previous probability is the probability that we get a student that's sports given that we know they are a girl. So one way to think about this, let's say that let me do a crude drawing. We have all of our students lined up in the hall that took part in this survey, and we know that they're girls. So in other words, we're going to pull out all of the girls, and all the girls are going to come stand in a group over here, and we're going to say out of this group of girls, right, we're going to figure out the probability out of this group that they like sports, right? So our denominator here is changing, right? The probability that out of the girls, so how many girls were there? There were 251 girls. And out of those 251 girls, how many of the girls like sports? 30. How about the probability that they are a girl given that they play sports? So again, if you'll look at my crude example, what we've done is we've taken the whole student population up here, and this time we've pulled out only the ones that play sports. So we said, all right, everybody that's focused on sports, come over here. And out of this group, we're now going to figure out how many of those folks are girls. So now, out of the sports folks, there are 90 of those, and there are 30 girls out of the 90. So what is always nice about math is we have these symbols and these abbreviations for everything. And so for conditional probability, this is our setup for conditional probability. Again, this is the probability that B will occur given that A has occurred. That's what you're looking at right here. Probability of B given A. And in order to set this up, there's a formula for us. I'll just write it out myself. The probability of B given that A has occurred, this is one we want to pay attention to. That's the probability that B and A happen over the probability of A. Right? We could also write the probability of A given B, and that would be the probability of A and B over the probability of B. Quick way to remember this stuff, the second one here is always the one that's in the denominator. B is second here, probability of just B is in the denominator. So let's take a quick look, excuse me, at an example. What if we wanted to, from this table, figure out the probability that someone loves sports given that they were a girl? Let's just plug it into the formula above and make it work. So this would be the probability of sports and girl over the probability, and again, girl is second, so girl will come there. Find the numbers above. The probability of a sport and a girl would be 30 out of 478. And the probability that we just get a girl, just a girl, would be 251 out of the 478. And this would simplify to 30 out of 251. And I think we just saw that on the previous page as well. Yep. Probability of sports, given that they are a girl, 30 out of 251. So we can look in the table and get it, but this formula also works very well if we can remember that, if we keep working with it. So quick mention here, something that's disjoint means that there are no outcomes in common. So if we have a house, some houses have pools, right? Some have garages, some have both. The fact that there's an overlap, this would mean that these two things are not disjoint. Something that would be disjoint. The colors in a traffic light. There is no overlap, no matter what you try to tell an officer. There's no overlap. So these things are disjoint because they don't overlap. As a heads up, another word for disjoint is mutually exclusive. And these two terms could be used interchangeably at any time, depending upon the text you're looking at. So, events that are not disjoint. This is going to be an alteration of our previous addition statement. When we see A, we want the probability of A plus the probability of B. But the issue here, if we wanted to figure out the probability that something's an A or B, all of a sudden the probability of A, there are three things out of the five in A. The probability of B, there are three things in B. There are three numbers in B. So if all of a sudden I did the probability of A or B, that would turn into 3/5 plus 3/5, which is going to violate one of our probability rules. We're over 1. Well, the issue here is that we're double counting 3. So in order to account for that, what we need to do is make sure that you always subtract the overlap. So your new addition rule will always be subtracting that overlap. So for us, there's one thing in the overlap. Now we're back to 5 out of 5, 100%. The fact that the probability we get something in one of those two would obviously be 100% because there's no other numbers. We just have those numbers. So make sure to make this adjustment to your addition rule. We're always going to subtract the overlap. Whether or not there is one, we always subtract it. So let's say that we take a look here. 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% a blood test, and 22% are given both. So where we put these things, right, 22% are given both. We know that 78% given just a breath test, or are given a breath test, and 36% are given a blood test. So what we can do with that overlap, right, if we wanted to figure out the probability that you're given a breath or a blood test, well, if we just did probability of breath plus the probability of blood test, this would cause a problem because 0.78 plus 0.36 is over 1. Well, the issue there is some people are given both. So what we need to do is go ahead and fill in the rest of my, table here. So if 22% are given both, that means that 56% are just given a breath test, and 14% are just given a blood test. If we go down here to the bottom and remember our new addition rule, don't forget we need to subtract the overlap. So again, what we've actually done here when we just do 0.78 plus 0.36 is we're double counting that 0.22. So make sure that you take out the 0.22, and that would tell us that 92% of people are given a breath or a blood test. Well, that could be kind of problematic too because there's a group of people out there obviously that aren't accounted for. Right? If we add up our entire sample space, whether it's just a breath test, just a blood test, or they get both, that's 0.92. We still got 8% of the population out there. And what that is a probability that no tests are administered. So the probability of none is 0.08. One thing we always want to make sure we take into account is this kind of, I'm going to say, hidden group out there where there is a none, right? Where there's nothing happening. Uh, a better way to organize these would be to make a table. I think the tables are a lot easier for us. And so what we do is we take our two different scenarios. They're either given a breath test or they were given a blood test. And we're going to kind of put this all together. Now, overall, the total is always going to be 1. So 78% of people are given a breath test. So breath test, yes, 78%. 36% given a blood test. And then 22% get both. And so what we're going to do here is fill in all the gaps, summing things together. So this row should add up to 0.36. This column should add up to 0.78. And then each column should sum together, and each row should sum together to be the total. So if 78% of people are given a breath test, 22% of people are not. If 36% of people are given a blood test, that means that 64% are not. And then the final piece, because again, each row should total, add up to be the total, and each column should also add up to be the total. And that's a real quick way to check. And so the missing piece here, 0.08. So what we can pull from this, right, 0.08 is in the no and no category, which means that they were given. So the probability that you were given no test is 0.08. The probability that you were given the breath and no blood test, right? So that would be you were given the breath test, and you were not given the blood test. Where do those two overlap? That would be right there at 0.56. So the way that I look at this, the table actually makes it a lot easier to pull information we need. Um, let's say that we wanted to um, go a bit further. We can do some conditional probabilities with these things. Um, so let's say that we want to find the probability that an individual is administered the blood test, given that they already took the breath test. Right? The officer stops them, gives them the breath test, and they want to go further with that group of individuals and give them a blood test. So we know that they've already been given the breath test. They're going to take them in for further evaluation, whatnot, and get the blood test as well. So another way to think about this, we know at this point that we've gotten everybody out of this 78% of people right here that have been given the blood test. We're going to separate that group and then find the probability that an individual is also given the blood test. So we'll set up our conditional. We'll follow the conditional rules. So this would be blood and breath. Look at the probability that you're just given a breath test. So blood and breath. Kind of clean this up a little bit. Blood and breath test right there. The probability that you were given a breath test, 0.78. And so out of the 78%, excuse me, sorry, my calculator. So essentially about 1/4 of the folks that have already been given a breath test are also given a blood test.